Achilles and the Tortoise is one of the most famous thought experiments. It, together with the arrow paradox, a ponderings of Zeno, a character in Aristotle's text, Physics. Both after millennia of rigorous philosophical thought, only have proposed solutions. Let's start with Achilles. One of the strongest men in ancient Greek mythology, it wouldn't be hard to imagine he can cross half the distance of a 100-meter race in just one time interval. The next half in the next time interval, and so on. The man is racing a tortoise, an animal not in particular rush for anywhere. It will eventually outlive all of its competitors, after all, but today is a special occasion where the tortoise might give it a shot. The tortoise crosses 2 meters every finite time interval. Tortoise emerges victorious, Achilles never reaches the finish line. I want to consider both paradoxes parallel to each other, so at the same time, here is the archer who fires an arrow. At any durationless instant of time, the arrow is neither moving to where it is nor to where it is not. It can't be doing either because it already is where it is. No time has elapsed for it to move to where it is not. In other words, at every instant in time, there is no motion occurring. And if that is the case, then if everything is motionless, at every instant of time, there is no motion. Before I continue to how we might approach Zeno's paradoxes, neither of them are officially considered solved. There are philosophical oppositions, but bizarrely, they are rarely considering physics. Upon hearing Zeno's paradoxes, Diogenes the cynic simply stood up and walked without saying anything. Aristotle's objection, as summarized by Thomas Aquinas, was that instants are not part of time, for time is not made up of instants any more than a magnitude is made up of points. It does not follow that a thing is not in motion in a given time just because it is not in motion in any instant of that time. In his 2003 paper, titled Zeno's Paradoxes, a Timely Solution, Peter Lint considers some implication of quantum physics, namely Heisenberg's uncertainty principle. The principle states that a particle's velocity and position cannot both be determined in an instantaneous measurement, not because of the limits of our measurements, but rather because those attributes of the particle simply do not exist, in the way classical objects are considered to have a definite position in space and a velocity. Therefore, Linz argues, instants do not physically exist as assumed in Zeno's paradoxes. In fact, if you were to continually repeatedly measure a particle's position or velocity or some other characteristic, you can quite literally arrest its time evolution. In the process of discussing and examining a system in the way Zeno described more than 2,400 years ago, what he suggests would happen, no motion possible, does actually happen. This effect in experimental physics is known as the quantum Zeno effect. We could even consider some very advanced physics concerning the unification of gravity with quantum mechanics, arguably the main objective of modern physics as a whole. One of the main candidate theories, which takes on this task, is called loop quantum gravity. In quantum mechanics, fields describing particle interactions on the subatomic levels are considered quantized. That means their fabric is discrete rather than continuous. Such are all the fields describing the quarks, leptons, and 3 of the 4 fundamental forces of nature. However, gravity, as described by Einstein, uses literal spacetime as its field of influence. That is partly where all the issues of unification stem from. Loop quantum gravity considered space and time as a quantum field with the Planck time and the Planck length as their fundamental, indivisible dimensions. These are unimaginably small, but are also the hard limit. You cannot have half a Planck length the way you can have half a centimeter. This is by definition impossible. The German physicist, mathematician and philosopher Hermann Weyl recognized this hidden assumption in Zeno's paradoxes that between any 2 points of either time or space there can be pointed another. If instead there is only a finite number of points of time and space between 2 points, then there is no paradox. Now with a little maths, we can actually determine who will finish the race first, Achilles or the tortoise.